ازيكم يا شباب، عاملين ايه؟ يا رب تكونوا كلكم كويسين. Today we are going to discuss another example for operation research model. Three factories, A, B, and C, each produces 4,000, 6,400, and 1,600 units of product J, respectively. Three warehouses each requires 2,400, 3,600, and 6,000 units of product J from three factories. The above information, together with the unit transportation costs from each of the three factories to each of the three warehouses, is given in the table below. Here's our table. We just put the given information in the table like we said in the previous videos. Okay. Our requirements. The first one, find the transportation table according to northwest corner method. The second one, find the transportation table according to least cost method. The third requirement, show your optimal distribution to minimize total transportation cost. The last one, what the total minimum cost. Here's our table, which is given in the example. We're going to write it again, but the difference here that we write the number of costs in dollar in the upper left for the cell. $10, $30, $4. Like we said in the previous video, that northwest corner method depends on starting from this row, the left of it, like this rectangle. But the difference here in this example, we divided the rectangle into 4 sections. Section number 1 is that we write down the cost of dollar, the number of costs of dollar, and here we're going to define the starting point for starting the solution. If it's going to be 2,400 or it's going to be 4,000. And like we said before, we make a comparison between the number of quantity produced and the number of quantity required, which means that I'm going to choose the least number, which is 2,400. It's more shown here. We chose the 2,400. Then I'm going to subtract this number from that number. So I'm going to make a small line over this number, and instead of 4,000, I'm going to write 1,600. Then I'm going to move for the next cell, which is AY. Then we're going to make another comparison. If I'm going to choose 1,600 or 3,600, and of course we are going to choose the least number, which is 1,600, and we write down here. When we write down the 1,600, we are going to make a small line on the new number and write down 0. So AZ will be empty. And also we are going to subtract 1,600 from 3,600, and we remain 2,000. When we made the comparison and cell AX between the number 2,400 and 4,000, we chose the least number, which is 2,400, and we subtracted it from 4,000, so P remains 1,600. So this number, we will make a small line above it and write down 0 because it's over. So the cell PX and cell CX will be empty, so I will make small cross in it. Okay, the next cell PY, because this cell AX, it's empty. So when we make the comparison between the 2000 that remained from the subtraction 3600 minus 1600, it will remain 2000. When I make the comparison between this number, the 2000, and 6000 and 6400, of course I will choose the least number, which is 2000. Okay, then we're going to make a small line above the 2000, the new number, and write down 0. So the cell CY will be empty. We make a small cross in it. Then we're going to move to cell PZ and also make a comparison. When we chose the 2000 from the quantity requirement, I should subtract it from 6400, so P remained 4400. Okay. When I make any comparison between number of quantity requirement row or number of quantity produced column, when I choose the least one, I should subtract from the bigger one. Like here, when we chose the 2000 instead of 6400, we should subtract it. Subtract the 2000 from 6400, so P remained 4400. So I should put small line over the old number and write down the new one, which is, like I said, 4400. Then in PZ, like we said, we make the comparison between the new number, which is 4400, and 6000. And of course I'm going to choose the 4400 instead of 6000. So when I'm subtract the new number, which is 4400, from 6000, it will remain 1600. So the last cell in this table, which is CZ. So our last cell in the table to be solved is CZ. There is only one number left, 1600 instead of 6000, and 1600, so there is no comparison. And like we said in the previous videos, when the last two numbers are the same, then my solution is correct. So the final result from this method, northwest corner method, will be 161,200. Now we're going to start to solve the next requirement, which is least cost method. Okay? We said in the previous video, to solve this method, we should start from the least number of cost. These are the number of cost. So of course the least number here is $1. So I'm going to start from this cell. Then I continue my solve normally. I choose from the 6400 or 6000, and I surely I will pick the smallest number, which is 6000. Then I'll subtract it from the biggest number, which is 6400. It will remain 400. So I'm going to put small line over the 6400 and write down 400. And also make a small line over that number and write down 0. So AX and CX will be empty. So I'm going to make a small cross in each cell. And that slide, it's showing more than the last one. When I make the comparison between that number and chose the least one, and this cell and that cell is crossed because it's empty, because this number is turned to 0. Then I move to next slide and choose the next small number of cost, which is 10, and make the comparison between quantity required and quantity produced and choose the least number. Of course, I'm going to choose the 2400. Then I will subtract it from 4000. It remains 1600. So we put small line over the we put small line over the old number and write down the new number. And also we put small line over this number and write down 0. So cell PX and cell CX, it turns to empty cells. So we put small cross in each cell. Then we're going to move to next cell, which is CY, because it contains the least number of cost. Then make the comparison between that number and shows the least one, which is 1600. So we write down here that number 1600 and subtract it from 3600, so it remains 2000. Put small line over 3600 and write down 2000, and of course small line here and write down 0. Please don't forget this step, it's very important. Okay, then we are going, which is AY contains the least number 30. Then make the comparison between the 2000, the new number, and 1600, also the new number, which is remain from this subtraction. Then write down the least number, which is 1600. Okay, when I subtract this number from the bigger number, which is 2000, remains 400. Make a small line over the 1600, the new number, and write down 0. And make small line also here over the 2000 and write down 400, the new number. The last cell remains, which is PY. There is only 2 numbers left, 400 here from the last subtraction and 400 here also from the last subtraction. So like I said, when the last 2 numbers is equally or the same, then your answer is correct. So the cost of transportation according to least cost method result is going to be 126,000. So now we are going to move for the last requirement, which is the optimal distribution. But at first, let's read some of our instructions. First, optimality. Now phase 2, optimality, obtains the optimal solution based on the initial basic feasible solution originated from phase 1. One method will be studied, stepping stone method. Step of the stepping stone method. First one, select any unused cell square to evaluate. Second, beginning at this square, trace a closed path back to the original square via squares that are currently being used. Beginning with a plus sign and the unused corner, place the alternate minus and plus sign at each corner of the path just traced. Calculate an improvement index by first adding the unit cost figures found in each square containing a plus sign and subtracting the unit costs in each square containing a minus sign. Repeat step 1 though 4 until you have calculated an improvement index for all unused squares. If all indices are 0, you have reached an optimal solution. Select any unused cell square to evaluate, like for example AZ, PX, CX, CZ. So we're going to start from the first cell, which is AZ. Here's our cell, AZ, the empty one. So going to make my transaction 4 plus 30 minus 40 plus 1. Here it's more showing the impact of transferring one unit from A to Z, plus 4 minus 1 plus 40 minus 30 equal plus 44 minus 31 to equal positive 13. This means that transporting one unit from A to Z increases the cost of transportation by $13, so I do not recommend that. This transaction, different from what I said, but it's the same. If you do plus 4 minus 1 plus 40 minus 30, or plus 4 plus 40 minus 30 minus 1, it will come up with the same result, which is positive 13. Next cell, which is PX 30, so the transaction going to be 30 plus 40 minus 30 minus 10, or 30 minus 10 plus 30 minus 40. So, like I said, the impact of transferring one unit from P to X equal plus 30 minus 40 plus 30 minus 10, come up with plus 10. This means that transporting one unit from P to X increases the cost of transportation by $10, so I don't recommend this. Moving to next cell, which is CX. But here there is a tip. We can do it, or we can do the transaction according to 40 plus 20 minus 40 plus 30, because this is empty cell. So the right transaction is going to be 40 minus 20 positive or plus 30 minus 10. The bigger square, not this one. That one, the bigger one from A. So the impact of transferring one unit from C to X equal plus 40 minus 20 plus 30 minus 10. Come up with plus 40. This means that transporting one unit from C to X increases the cost of transportation by $40. So I don't recommend this or that. So the last empty cell, which is CZ, the transaction is going to be 3 plus 20 minus 40 minus 1, or 3 minus 1 plus 40 minus 20. Like I said, the impact of transferring one unit from C to Z equal plus 3 minus 1 plus 40 minus 20, come up with plus 22. This means that transporting one unit from C to Z increases the cost of transportation by $22. So I don't recommend that. Transportation plan according to least cost method is optimal. Transporting 2,400 units from A to Z, transporting 1,600 units from A to Y, transporting 400 units from B to Y, transporting 6,000 units from B to Z, transporting 1,600 units from B to Y. And that's it. Thank you all. And if anyone needs anything, please contact us within OR